In this video, we'll learn about the difference between probabilistic and non-probabilistic sampling methods. We'll give some examples as well, and we'll finish off with an account of sampling bias and a few points about sample size, and we'll also talk about the non-probabilistic methods. The content of this slideshow is almost entirely inspired by Chapter 8 of Ehrlich and Joubert. So if you've got any queries or you'd like further clarification, please refer to the textbook. Before we launch into the content, let's just be clear the difference between the study population and the sample. The study population is the population from which your sample is drawn, and it is the population to which your statistical findings may be extrapolated or referred back. In other words, for inference. In this example, you've got a study population of women up to 250,000 odd, and we've taken a random sample of 100 to participate in this study. So the study population is all the 250,000 women. The sample is just 100. Just a few words now about the difference between probabilistic samples and non-probabilistic samples. That's quite a mouthful. You could, if you like, just talk about random and non-random. It means more or less the same thing. Probabilistic samples are those that are used, that are selected using random processes or chance, entirely based on chance. And there's nothing extraneous that is affecting the composition of your sample. So it's likely to be representative, and statistically the findings can be inferred to the population from which it is drawn. Non-probabilistic samples, on the other hand, uncertain representativeness, cannot necessarily generalize it to the population, and the data are unsuitable for statistical analysis. With regard to the probabilistic methods, we're going to describe 4 in this slideshow: from simple random sampling, SRS, systematic, stratified, and cluster random sampling. The first probabilistic method is simple random sampling. It's the best known one, otherwise known as SRS. And in this method, every member of the study population has got an equal chance of being selected into the sample. Whether or not they are selected depends purely on random chance factors. So in that way, we try to eliminate any possibility of bias in the sample. One of the drawbacks is that you do need a sampling frame in order to be able to do simple random sampling. In other words, you need a list of all the members of the population, and you need to be able to give each one a number so that you can select a random sample. And this is often not possible, and it may not be practical. You can use random number tables once you've enumerated your population, or you can use a reliable app. You might also want to use MS Excel, and I've also provided a short video separately which shows you how to use MS Excel in order to obtain a simple random sample. The next method of probabilistic sampling that I'm going to describe is systematic random sampling. In this method, you might, for example, want to take every 10th patient arriving at a clinic, or you may want to go and interview the people in every 3rd house in the street, and so on. I've done it previously with every nth bed, every 9th bed in the hospital to see where the patients came from. Now, with this method, what you do is for the first person, you choose a person at random, a number at random between, say, 1 and 4, and then that will be your starting point. And after that, you take every 4th patient. If you wanted to take every 9th person, then you would start with a random number between 1 and 9, and then after that, choose every 9th patient. We move on now to stratified random sample. You may have strata in your population that you would like to do the estimation for each stratum separately. For example, I may want to know what is the average height of women separately from the average height of men. Now, stratification is also useful if you've got a small subset of the population with very, very different characteristics from the general population, and you want to make sure that variability is somehow reflected in your estimates. It's also suitable when you've got between the groups, you've got a bigger variation between the groups than what you find within the groups. And strata can be anything. It can be gender, it can be faith, socioeconomic status, age group, and so on. The last probabilistic method that I'm going to talk about is cluster random sampling. With cluster random sampling, you choose starting points at random, and these might be houses, for example, in a district, or it might be schools in a district, or it could be classes within a school, but you choose starting points at random. And then you go to each of the selected starting points, and there you might, for example, choose to interview every child in the class, or every 10th child in the class, or even a simple random sample of 4 out of each class, and so on. So it's a sort of two-stage process. Now, there are drawbacks with cluster sampling. It's less efficient. You virtually have to double the sample size in order to get the same level of precision or power. And the analysis is more complicated because it must take the clustering into consideration when analysis is performed. So why would we do it? Well, we do it when there's wide geographic variation or spread or dispersion of the people in the population, or if we do not have a sampling frame, then we would resort to cluster random sampling. Now, there's some pitfalls that might occur while we're sampling that may lead to bias. So we should be aware of these and try to avoid them. For example, if we're using telephone numbers in a telephone book as a sampling frame, you would automatically only include those people who A, have telephone numbers in the book, and B, agree to have their numbers listed. So this could lead to bias because the people who are not in the book may be quite different from the people who are in the book. Also, you might visit residences that you've chosen randomly, but you only go there during the working hours and people are not at home. So the people who are at home might be quite different from the people who are out working. You might also get refusals to participate, in which case, especially if there are sensitive questions involved, the people who agree to participate may be very different from those who say, no, I'm not going to participate. And you might also get poor response rates, for example, from postal surveys. And then the responders may differ from the non-responders. So this can lead to bias. We need to be aware of this. Determination of sample size is the most common reason for people to consult a statistician. It's a very important topic because if your sample size is inadequate, if you're making point estimates, your estimates will be imprecise or lacking the precision that you would like. And if you're doing analysis, the power of your study, in other words, the ability to detect a difference if there really is one, will be diminished if your sample size is not sufficient. There's some nice examples in the appendix of Ehrlich and Joubert, and I suggest that you go and have a look there. But don't worry, in later modules in biostatistics, you will learn about how to calculate sample size. Non-probabilistic sampling methods are often used in qualitative research. However, you do sometimes get some mixed methods research as well. For example, when you want to determine what items to put in a questionnaire for a quantitative study, you may use qualitative methods in order to obtain or identify the best items to include. So these may be encountered even though you consider yourself perhaps a quantitative researcher. There are quite a long list here. If you do one of the modules available from the school in qualitative research, you will learn more about them. We're not going to go into a lot of detail here. I've listed them down the side here. I've got just a warning about the use of the word purposive sampling, which I'll talk to just now. If you want more detail about these methods, you can look in Joubert and Ehrlich, but I'm not going to talk about them more at this stage. Purpose of sampling is very useful for people who are doing certain kinds of qualitative research, such as focus group discussions or in-depth interviews. This is the desirable way in which to identify participants in such a group. But it's become quite common for people to use the term to describe, for example, if you decide that, oh, I'm going to do a study in 3 factories because I think they're fairly typical factories, or they're close to where I live, or whatever. And then people say, oh, that's a purpose of sampling. In fact, this is not correct. Those 3 factories now are your population, and you're going to work within those 3 factories to identify your samples within those factories, and your sampling should still be of a probabilistic nature within those. So you've used purpose of method in order to identify your population, but not your sampling. So don't confuse the two.